Hi gentlemen, welcome to our project. Our project title is Remote Patient Monitoring System using LabVIEW. Here we have a remote module. It consists of a power supply and a PIC microcontroller where you burn the our coding. It uses 16F73 coding. Here we have a ECG module connected to a patient. Due to ECG modules is a very millivolt range, so we have a instrumentation amplifier AD620. The amplifier boosts the signals, and you have used UA741 IC to improve the gain factor. We are connecting to the system using the audio jack input to the LabVIEW, and this is a remote module through which we are going to get the data from the Zigbee operator used by a patient. We are connecting this to the LabVIEW using the RS232 USB conversion factor. This USB port is connected to the COM3 port of our system. Here now we will see how it works. This is the pulse oximetry. It's used to calculate the pulse rate of the patient. Once the forefinger or the finger is inserted into the pulse oximetry, it counts the heartbeat, and the corresponding output will be present in the pulse count rate. It will be calculated for 1 minute. If the normal pulse rate of a patient ranges from 50 to 100 counts per minute. If it is critical, a message will be displayed here, and a corresponding LED indication also always present. This is a ECG module which indicates the patient's ECG waveform, PQRST waveform. Still we have not run the module. Now we will see how to. First we will see the pulse now. Once let us consider I am the patient. If I have inserted the forefinger, so the corresponding LED blinks and the count also increments in our LabVIEW. It's incrementing. You can see that the waveform of patient. Since it doesn't have a required amount of power supply, it has not reached our pulse rate, so it is in the low state, and alert system, a red alert system is indicating. If the pulse rate is increased to above 50 and ranges within 100, the normal message will be displayed. Next we will see about the ECG module. We are using the 3-lead system here. The positive electrode is connected to the right arm of the patient, and the negative electrode is connected to the left arm of the patient. A common ground is connected to the leg of the patient. Due to time constraints, we have not yet completed this project, but we are yet to complete this project. This instrumentation amplifier is used here. The pulse count is transmitted through the Zigbee module. This module will be attached to the patient system, and this Zigbee transfers the data to our remote control system. Through this, we are connecting to the LabVIEW. So the data received from the Zigbee receiver will be transferred to the LabVIEW system. Here we will have the pulse count. You will see now our block diagram. This is our block diagram. we are connected to the COM3 port, and we are using a Visa port, Visa open, Visa read, and a Visa close. Since we are using a USB port, we are using a Visa port here. This will acquire the signal, and we'll compare with our test signals processed before, and we'll have a count here. The pulse count will be counted, and the pulse we will check for the range here. If it is within the 50 to 100 range, the normal range of the patient will be displayed, or else the high or low signals. It ranges upon the 50 to 100 range. If the pulse rate goes below 50, the low rate will be displayed, and if the pulse rate goes above 100, and the high rate will be displayed. If your finger is not inserted, simply small null character display will be displayed. Here we have another module. This is the trips count meter. It counts the trips count when the drop falls. We are using IR sensors. It will count each drop, and if the drop count decreases or increases, an alert message will be displayed here. We can also implement this system using a LabVIEW. We have not yet planned, but if at all hardware and fundings are provided, we are ready to establish this project.